Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Tilt Controls by Nicholas Duhale, and I'm assuming it's because we're trying to control things with these tilted aspects. Here are the rules. We have normal Sudoku rules apply, which means on every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Box borders divide blue lines into segments with the same sum. So for example, these 3 digits must equal the same sum as these 2 digits because the box borders divides that line into the segment here and the segment here, and they must equal the same sum. So that's how region sum lines work, which was what are these tend to be called. Along green lines, adjacent digits differ by at least 5. So for example, if this were, say, a 3, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. Along pink lines, digits form a consecutive sequence in any order. So, for example, this could be something like 2, 5, 4, and 3. And that would work because they form a set of they form a consecutive sequence, right? 2, 3, 4, 5 is a consecutive sequence. What you could not have, though, is something like 2, 3, 4, 3, because that's not considered a consecutive sequence because you have a repeat on that line, and that is not allowed. And finally, we have digits along the indicated diagonals must sum to the given total, and digits may repeat if allowed by other rules. So for example, along this diagonal, it must add up to 9. Along this diagonal, it has to be even, an even sum. Along this diagonal, it also must be an even sum, etc., etc. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So these are all going to be the lines plus a single other digit. So this adds up to 9. So to add up to 9, which is an odd sum, we know a 2-length Renban means that you have to have 2 consecutive digits. So that means one of them is going to be odd and one of them is going to be even, which adds up to an odd sum. And since these two add up to an odd sum, that means we have to have an even digit here to add up to 9, an odd sum. This must add up to an even sum, and we know these 2 digits, or these segments, add up to the same sum, which means it's 2 times something, so it's an even sum here. Well, to add up to an even sum with an even sum, you need another digit that's even. This adds up to an even sum. That's 4 consecutive digits, which means you have 2 evens and 2 odds, which is also an even sum, right? So, right, if you have 2 evens, they obviously add up to an even sum. If you have 2 odds, they add up to an even sum, and even plus even is an even sum. So that means this has to be even also. These 2 digits must sum up to the same sum as these 3. So again, this is equal to 2 times a sum, which means that's an even number, which means we are guaranteed that's even. So the rest of the column has to be odd because we have 4 evens in column 9. Now let's take a look at this. Here, this must add up to 10, whereas we know this is an odd sum here. To add up to an odd sum with an odd sum, you have to, to add up to an even sum with an odd number, the other number has to be odd. So this must be odd. I think it's going to be the same here. These add up to an even sum because these sum up to the same sum as that. So this is odd. Again, this is two odds and two evens here, which adds up to an even sum. To add up to an odd sum, it has to be odd there. And the same with this. This sums up to the same sum as these two. So that's an even number there. To add up to an odd number, that must be odd, which means the remaining digits in this row have to be even because we have 5 odd digits in row 9. Now, these are two even digits which are 5 or more apart from each other. Well, the only pair that can work is 2 and 8, which means this is 4 and 6 as a pair. That means this has to be an odd digit because this must be the only digits which is 5 or more away from 4 is 9, and the only digit which is 5 or more away from 6 is 1. So this must be 1 or 9 there. What about this diagonal? So this is 4 digits adding up when in a sequence, so that must be 2 evens and 2 odds, which is an even sum. This is an odd sum because it has 1 odd and 1 even digit, and this is an even. So therefore, since this is even here plus even here, and this is odd, this has to be an odd value. Well, this is an even sum because, again, we have 2 odds and 2 evens. This is an odd sum. This is an odd sum. So this is an even sum here. And this is even sum. To add up an even sum, this must be even there. Interesting. This adds up to 10 without 4 and without 6. The possible combinations then are 1, 2, and 7. No 1, 3, 6, no 1, 4, 5, or 2, 3, 5. So we're guaranteed a 2 on one of these cells. And it has to be 2, because 2 can't be here because of the 2 there. And it could be 1, 7, 2, 1, 7, or 2, 3, 5. And these have to form a pair that is consecutive. So we have a 2 guaranteed here. Where is 8? 8 could be any of these 3 digits here. So if 8 is here, it has to be with 1, and then that's 9. But that's not possible. So if we have 8 here, this can't be 1, it's 5 or 7. Because we have 2 and 1 or 2 and 3 here. If we have 1 and 8 here adding up to 9, the 1 here would eliminate 1 in the box, and the 9 here would eliminate 9 here, which is not possible. So 8 cannot be any of these digits here. Where is the 8 in box 7? It has to be here. So this red band line has to either be 5, 6, 7, 8, or 6, 7, 8, 9. We are not sure. Okay. 9 cannot appear anywhere here on the region sum line because 9 plus another digit is not going to sum up to a single digit. So therefore, this must be 9 here, which makes this 4, which makes that 6. Remaining digits in this box then. So we know these add up to 10. We have 10 plus 17, 27, plus 4 and 6, which is 37. So this is always going to be 8 here, and this has to be either 1, 7 or 3, 5. We're not sure which. So we know that's an 8, and therefore that's even. This is 8, and therefore even. This can't be 6 because of 6 in the column. So this must be an odd digit here. We have 8 here, so 8 has to be one of these two digits here remaining. This adds up to 9, and we have an even digit here. So this must be one odd, one even. So we could have 1, 2 with 6 there. What else can we have? 2, 3 with 4, or 3, 4 with 2. So 1, 2, 6, 2, 3, 4, or yes, 2, 3, 4, and 2, 3, 4. So we're guaranteed one of these three digits is a 2. Okay. These two digits have to add up to what that digit is, but we don't have as many restrictions. 8 has to be one of these three digits. We don't have any information here, unfortunately. Hmm. Um. Hmm. Hmm. I don't really have that many restrictions, unfortunately. Hmm. 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 So if this is even, it has to be 4 or 6, which means this would be 3, 5, 7 if it were odd. If this is odd, it could be 1, 3, 5, or 7, which could be next to 2, 4, or 6 there. So that doesn't help us very much either. Same here. 4 and 6 next to 3, 5, or 7, but this could be 1, 3, 5, 7, or 9. So that could be 2, 4, 6. Can't be 8 because of 8 in the row. Where is 8 in column 9? It has to be one of these two digits. It can't be there, can't be here because of 8 in the row. Huh. Okay. These digits can be 1, 3, 7, or 9. 9 can't be here, so this can't be 3. If this were 3, that's none of these digits remaining are 5 or more away from it. Phew. This has to be at least 3. Well, we know this adds up to 9. These 5 then have to add up to at least 15. So that means this must be at least 6. Right? 15 minus 9 is at least guaranteed 6. um, hmm. That doesn't tell us too much. There's only one even digit in box 6. That's interesting. Does that tell us anything? Not particularly. Because we don't know where the even digit is. We do know 6 has to be one of these two digits, but that doesn't tell us too much either. Oh, 9 eliminates 9 here. We don't know if there is a... Oh, 9 eliminates 9 here also. So if there's a 9, it has to be there. Interesting. That doesn't tell us much. Oh, we know these are odd digits. Okay. Hmm. One of these has to be a low. To be 5 or more away from each other. That means we have 2 guaranteed lows here. To add up to 9, it's either going to be 1, 2, 6 or 2, 3, 4. Oh, this can't be 2, 3, 4. If this is 2, 3, 4, we are guaranteed a low here, and the minimum these digits could be is 5 and 6, which adds up to not a digit. So this cannot be 2, 3, 4. It must be 1, 2, 6 here. So this has to be 1, 2, 6, which are consecutive. That leaves this as a 6. And the remaining digits in this box, or in column 9, are 2, 4, and 8. That eliminates 2, 4, and 8 in the rest of the box. So this has to have one low here. So it's either 3 with 8 or 9, or 4 with 8 or 9. 4 with 9, right? So this is 3 or 9 here. Therefore, this cannot be 3 here. If this is 3, that would force this to be a 9 here. and that would eliminate all possibilities for this cell here. So if this is 3, we can have this is either 3, 9, 3 with 8 or 9, or 4 with 9. So we could have 3, 4, 8, and 9 there. This must be either 3 with 5, adding up to 8, or 4 and 5, adding up to 9. Because we don't have... One of these has to be 3 or 4. That means the minimum here is 3, 4, or... You can't have 3, 4. You could have 3, 5, or 4, 5 here, which means 5 is guaranteed to be one of these. That means this is 7, 8 or 9. If this is 3, that would mean this is 4, 5. It would have to be 3 and 8. So if we have 3 here, this is 4, 5 as a pair. That adds up to 9. This can't be 9, so 3 would have to be with 8 here. Or 3 could be here. If we have... So... We can't have 9 be there, then. If this was trying to be 9, that would make this 8, 3, and 5 adding up, and then 4 cannot be here because that has to be an odd digit. But you could have 3 with 8 here, or 3 with there and 9 there. Again, this can't be 3 here because that would force this to be 9 and eliminate all possibilities for that cell. So we know we have a 1 guaranteed here, which eliminates 1 in the rest of the box. So this can't be 1. So where is 1 in row 9? It has to be there. Remaining digits in box 3. So this is guaranteed to be 5. We have 1 out of 3 or 4 here, 1 out of 3 or 4 here. So no 1 through 6 here. This has to be 7 or 9, and this is 7, 8, or 9. So this Renban cannot be... It can be 4 through 7 or higher. So we have 4 through 9 there. This can't be 4 or 8 because of a 2, 4, 8 triplet in the box. We are guaranteed that a 7 is here, and we're guaranteed a 6 is one of these digits. We have a 1, 7, 9 triplet in column 9, which eliminates 1, 7, and 9 in the rest of the column. So this can't be 9. That's 3, which means this is a 4, 5 pair adding up to 9 here. So this is 9. That means this can't be 9. That's 7. This is 3 next to an 8, which forces this to be a 9 here. Which means the remaining digits here have to be 6 through 9 for this Renban to work. And this can't be 7, 8, or 9 because of 7, 8, or 9 in the row, so that's 6. No 8 here. 8 can't be here because of 8 in the column, so 8 has to be there, which makes that a 7. That eliminates 7 in the rest of the box and column. So we have an even here. This is odd. The remaining digits in row 1 are 1 through 5. Okay. 7 eliminates 7 in the rest of column 9. So this is 1. This can't be 1 or 7. It's 9. That leaves that as a 5. There's no 5 or 9 here because of 5 or 9 in the box. 5 eliminates 5 here, so it's 7, which makes this a 1, 2, 7 triplet, adding up to 10. That eliminates a 1 and 7 here. It's 3 and 5 as a pair. 8 eliminates 8 here, so where is 8 in column 2? It has to be there. That means the remaining digits on this red band, again, have to be 5, 6, 7, or 9. So no 7 here because of 7 in the column, no 6 or 9 here because of 6 or 9 in the column. That means we have a 5, 7 pair here. One of these two is a 6. That 5, 7 pair eliminates 5 and 7 in the rest of column 1, so that leaves just remaining digits as 1 through 4. We have 5 at most here. These digits can be 1 through 8, potentially, because 5 through 8 is the largest this red band could go. There's no 8 here or here. These can't be 6 because of 6 in the row and 6 in the column. This can't be 7 because of 7 in the column. This can't be 4 because of 4 in the column. Okay. This digit sees both of these digits here and this one. And this has to be 5, 6, 7, 8 or 6, 7, 8, 9. Either way, we are guaranteed a 7 on this red band, which means this cannot be 7, so this must be 5. That makes this a 5, 6, 7, 8, 9 red band. Or sorry, 5, 6, 7, 8 red band. 5 eliminates 5 in the rest of this red band, so this can't be 5, it's 7. This can't be 5, and this can't be 5 or 7, so this is 6, 9 as a pair. That should eliminate 6, 9 in the rest of the cells that see both of these cells. 7 here. Well, that doesn't help us very much. 7 eliminates 7 here. We know one of these two digits is a 7. What else do we know? We know one of these two digits is a 7. This cannot be an 8, so it's 2, 4, or 6. 2 could be next to 7 or 9. 4 is next to 9, and 6 is next to 1. Remaining digits here are 1, 3, and 9. That eliminates 1, 3, and 9 in the rest of the box. So these sum up to each other. So we've done the ren band here. We've done the ren band here. Remaining digits in box 2. We have 1, 2, 3, 4, 5, and 7. Obviously no 7s here, no 3s here. We have a 1, 2, 4, 5 quadruplet in row 2, which eliminates 1, 2, 4, 5 in the rest of the row. And this can't be 3 either. That makes that a 6. Huh. And that leaves that as a 9. 6 eliminates 6 here, so that's 9, which makes that 6. 6 eliminates 6 here, so it's 7, which makes this 6 there. That leaves that as a 7 there. Interesting. Remaining digits in column 2. We have 1, 2, 3 because it can't be 5 there. These are 1 through 4 in box 4. And this has to be 1 through 5. Not too helpful. 7 eliminates 7 here. So this Renban cannot contain a 7 at all. Therefore, it cannot ever go to 8. We have to have a 5. Okay, so this has to be 7, 6, 5, 4, 3. Sorry, 6, 5, 4, 3. Because we don't have a 7 available. So one of these two digits is guaranteed to be a 4. We also have a 3, 5 pair in column 2, which eliminates 3 and 5 in the rest of the column. This is 4, which eliminates 4 in the cells that see those both cells. So this cannot be 4 here. 6 has to be one of these two digits here. Um, 7 eliminates 7 here, and 7 here. So where is the 7 in box 9? It can only be here. This can't be 5 because of 5 in the box. So this is 3, 4, or 6 also. This can never be 6, because if that's 6, it would have to have a 5 there, or 7 there, and it can't be either. So there's no 6 here, which means 6 has to be here. That eliminates 6 from being there, so this can't be 1. Whereas 8 then, 6 eliminates 6 in the rest of the row here. This is 3, 4 as a pair. That eliminates 3 and 4 in the rest of the box, so that's 6. 3 and 4 eliminates 3 and 4 in the rest of the row, so this can't be 3. That's 5, which makes that 3. Which makes that 5, so these can't be 5 here. Therefore, this is a 3, 4 pair. This 5 eliminates 5 in the rest of the row and box. 1 eliminates 1 here, so this is 2 and 1. 2 eliminates 2 here, so that's 1. That eliminates 1 in the rest of the column and box. That leaves this as an 8. Remaining digits here are 2, 4, and 5 in box 8. Well, this can't be 8 and 2 because that adds up to 10, and that cannot be 1 or 2 here. So this must be 8 and 4, which adds up to 12, which would mean this is 2, 3 as a pair, or 8 and 5, which adds up to 13, which would be 2, 4, and 7. So we're guaranteed 2 is one of these digits, which means this cannot be 2. This has to be 3 and 4 here. That eliminates 3 and 4 in the rest of the cells that see both cells. So no 3 there. 6, oh, this is 6 here. That's consecutive only with 5. 3 is consecutive with 2 or 4. 4 is consecutive with 5 there. So this is 5. 9 cannot be here. Remaining digits in box 6 are 1, 3, 6, and 9. Obviously, 9 can't be here. 1 can't be here because of 1 in the row. 6 cannot be either of these digits. And 6 can't be here. We have a 1, 3, 9 triplet in box 6, which eliminates 1, 3, and 9 in the rest of the box. Also, 8 eliminates 8 here, so that's 2 and 8. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so that's 3 and 9 as a pair. 5 eliminates 5 here, so that's 4 and 5. 3, 9 as a pair eliminates 3 in the rest of the column, so this is 4, which makes that 3. 3 is consecutive with 2 or 4 here. So that's 2, 4 as a pair. 3 eliminates 3 here, so that's 1. And eliminates 3 here, so that's 6. We have, this can't be 9 because of 9 in the column. We have 2, 4 as a pair in column 6, which eliminates 2, 4 in the rest of the column. That leaves the remaining digits as 1, 3, 5, and 7, which are all odd. This can't be 1 or 7, it's 3 or 5. This can't be 5, it's 1, 3, or 7. Huh. Okay. If this is 6 and 3 added together, that's 9. So how would you add up to 9 here? 1, 3, and 5, or 2, 3, and 4? Okay. Where is the 8 in column 4? 8 can't be here because of 8. Excuse me, 8 in the row. 8 can't be here because of 8 in the column, so 8 has to be here, which means this can't be 8. Therefore, we have a 2, 3, 4 triplet in row 4, which eliminates 2, 3, and 4 in the rest of the row, so no 3 here. That's 5. That eliminates 5 there. That leaves this as an 8. Remaining digits in box 5, we have 1, 2, 3, 4, 7, and 9. No 7 here, no 7 here because of 7 in the row and column. No 1 here because of 1 in the row. Okay, 6 and 9 adds up to 15. So to add up to 15 here would have to be 3, 5, and 7. Which could work. Hmm. If this is 4, that makes this a 9, which makes that 3, which would mean 9 is there. So that's fine. Where is 2 in row 5? It has to be one of these 2 digits. So that eliminates 2 in the rest of the box. Where is 2 then in column 4? Can't be any of these digits. So it has to be one of these 2, which means this can't be 2 in box 2. Also, 1 eliminates 1 here, so that's 5. That leaves that as a 2 there. So this cannot be 2 here. So we have a 5 here. If it's 6 and 3, then this must be 1 and 3, adding up to 5. If it's 9 here, then this must be 3 and 7, adding up with the 5 to add up to 15. So either way, we're guaranteed a 3 here, which means this cannot be 3. That's 4, which makes that not 4, so that's 3. That eliminates 3 in the rest of the box and column. This is 4 here, which eliminates 4 here, so that's 5. It also eliminates 4 in the rest of the box. We have a 1, 7, 9 triplet, which eliminates 1, 7, 9 in the rest of row 6, so this can't be 9, it's 3. Obviously, this can't be 3 here. This is 15 anyways. Sorry, 13 with 5 and 8. Therefore, this must be 2, 4, and 7 adding up to add 13. That means this can't be 4 here. It's 3. 3 eliminates 3 here, so it's 9. So 6 and 9 must be the sum of 3, 5, and 7, because they must add up to the same sum. So we have 3, 7 here, that's 1. 7 eliminates 7 here, so that's 1, which makes this 9, which makes that 7, which means this has to be a 2, because 4 cannot be 5 or more away from 7. So that leaves this as 2, that's 4, this is 2. No 2 or 9 here. So this is 4. 1 eliminates 1 here, so that's 9. No 1 here, so it's 3, which makes that a 1. No 2 or 3 here, so that makes that 4, and that 1. This can't be 1 or 4 or 3, so that makes that 2, which makes this 4 and 2, which makes this 2 and 4, and that leaves that as a 3. Interesting. The break-in was interesting, but so was also the solving it after the break-in. So that was there are some interesting aspects here, particularly with the red bands and what those could be. Nice puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.